Welcome to the Mississippi Emergency Management Agency Public Education and Outreach Program Benefit Cost Analysis Video Training Series. The topic of this session is the BCA Damage Frequency Assessment Module for the purchase and installation of generators. This material was prepared by the Mississippi Emergency Management Agency's Office of Mitigation under a FEMA grant entitled Public Education and Outreach Mitigate Now Adult Campaign. The purpose of this grant is to develop, promote, and present programs and materials that increase awareness of mitigation and mitigation best practices. Both pre- and post-disaster mitigation activities are funded through FEMA's Hazard Mitigation Assistance programs. All requests for HMA funding require a detailed application and cost-effectiveness analysis along with a positive benefit-cost ratio. The BCR analysis is performed using FEMA's most current BCA software and is the subject of several training sessions like this one provided by MEMA. Hazard mitigation activities are also outlined in detail in other presentations and reference material found on the MEMA Public Education and Outreach Program website. All projects undergoing cost-effectiveness review using the FEMA BCA tool are loaded into the BCA software program using a step-by-step process. The 5 steps in the process are 1. Create new project. 2. Create a new structure. 3. Add or connect structures to the projects. 4. Start new mitigation, which is actually an analysis using various modules. And 5, export the BCA to archive the information for future use. In the Creating Projects and Structures segment, instructions were provided for the first 3 steps of the BCA process. That is, create a new project, create a new structure, and add structures to the project. If you have not already read the material, please review the information contained in the Creating Projects and Structures segment prior to proceeding with the BCA development process. Once the user has properly added a structure to a project, they are now ready to proceed to step 4 of the BCA process, Start New Mitigation. In this step, the user will select which of the mitigation modules will be used to determine the cost effectiveness of the project. There are 2 ways to reach the necessary mitigation information screen. Select the project's icon from the basic navigation toolbar. Then the user can highlight and double-click the arrow adjacent to the desired project on the project inventory screen. The project summary screen will then appear. The user must highlight the project and double-click on the arrow to the left of the project name. The mitigation information screen should then appear. The second method of reaching the mitigation information screen is to select the Start New Mitigation icon found in the Quick Start area of the home screen. A list of existing projects will appear. The user can select their project and structure from the list. The mitigation information screen should appear. The choices listed on the mitigation information screen are Flood, Hurricane Wind, Damage Frequency Assessment, Hurricane Safe Room, Tornado Safe Room, Earthquake, and Wildfire. In this session, we will review the use of the Damage Frequency Assessment module in conjunction with the purchase and installation of a standby generator. After the project is opened to the mitigation information screen, select the button adjacent to the Damage Frequency Assessment selection. Proceed by clicking on the Save and Continue icon found at the top right-hand corner of the display panel. If you've already set up the project, double-click on the arrowhead adjacent to the project name. The Damage Frequency Assessment, or DFA, module is used when there is not enough technical data available to use the full data versions of the BCA software, or the project is to mitigate the loss of function for a non-building, such as a utility, road, or infrastructure. The DFA module can be used for mitigation projects involving standby generators for non-residential structures, as long as the following hazard mitigation grant program conditions are met. 1. A generator that is a standalone project can be considered for regular HMGP funding if the generator protects a critical facility. Note that critical facilities may include police and fire stations, hospitals, and water and sewer treatment facilities. 2. A generator that is a component of a larger project, for example, the elevation of a lift station, is also eligible for regular HMGP funding, and the use of aggregation is permitted. And 3, portable generators are eligible provided that they meet all HMGP requirements as described in 44 CFR Section 206.434. It is important to remember with the DFA module that because of its flexibility and dependency on user-provided data, clear and acceptable documentation is a critical requirement. Documentation that does not support the analysis could result in an application not being approved. Damages and losses must be documented from at least one hazard event, preferably 2, with a known frequency that is based on 1. FEMA project worksheets or damage survey reports, 2. Insurance or repair records, 3. Newspaper articles citing other credible sources, or 4. More events with known frequencies will improve the confidence of the calculation. Frequencies associated with each hazard event must be documented based on 1. A comparison of observed wind speed to data available from sites such as the Applied Technology Council. 2. If the power outage is flood-related, documented data is available from a credible source such as the National Weather Service. And 3. Use of the BCA unknown frequency calculator is acceptable when its requirements are met. There are several key inputs specific to the purchase and installation of generators. Project useful life, according to OMB Circular A76, performance of commercial activities is 19 years. This value can be used as the default useful life value when performing the BCA. It may be altered based on the manufacturer warranty or other documentation that can demonstrate that the generator may be able to provide service for longer than 19 years. Analysts should use the 19-year project useful life first. Project costs. The cost of generators varies by size, installation, and purpose. The generator's size and specifications should be reasonable, appropriate, and necessary to continuing critical functions of the facility. The exact costs for generators, installation, and components should be provided by the subapplicant and included in the costs when performing the BCA. The next key input is the facility and value of service. For potable water, wastewater, police, fire station, and hospital facilities, analyses can be quickly performed using the FEMA BCA's Toolkit and the DFA module, which provides service values for these facilities. To use these values, the analyst will need some information regarding the population served by the facility. For example, if a generator is to be installed at a wastewater treatment plant, the analyst will need to know how many customers are served by the facility as well as how many days the facility was inoperable because of the power failure. These values can typically be obtained from the facility manager and can be provided on an official letterhead for documentation purposes. The next key input is the recurrence determination. Recurrence information used in the analysis may vary by location or by cause of power failure, such as wind or flood. The final key input relates to other benefits. Other benefits or costs avoided may be included if they are addressed by the generator project. For example, if the generator negates the need for temporary water in the future, or if the generator eliminates the environmental costs associated with raw sewage discharge. Once the DFA module has been selected, the following screen should appear containing the initial questions to be answered by the user. The type of mitigation is normally found in the detailed scope of work for the project. In this case, we will be concerned with a hurricane wind hazard and other project, so the user should select the hazard, then mitigation type pull-down menu buttons, and make the appropriate selection for each item. We will also be using historical damages for the basis of our analysis in our illustration, so the user should select the button adjacent to the historical damages response. The user will need to know how many damaging events have occurred that will be mitigated by the project. Minimum requirements are at least one hazard event with a known frequency and at least 3 events with unknown frequencies. For our test case, the user should indicate that one event with known recurrence interval will be used to generate the benefits or damages avoided by the project. A dialog box may appear reminding the user that they must know the year the structure was built. Press the Save and Continue button to proceed to the next page. The user will be prompted to enter pertinent information in the Justification Documentation box found on the lower portion of the display. To avoid error messages, it is important to enter information for each field in the Justification for Field box before proceeding to the next field. Simply click on the Justification or Upload Documents tabs and type in the reference, file, explanation, or calculation. Click on the Save Justification button before moving to the next field. A paperclip symbol will appear adjacent to the fields that have data entered correctly in the respective Justification for Field tab. The BCA tool also provides basic information or help for each field. It is accessed by holding the cursor over the data entry box or by clicking on the bar labeled Help found in the lower left corner of the display. By clicking on the applicable frequently asked question in the dialog box above the help bar, the user is linked to a display of additional information on that topic. For example, if the user selects the first help question, How do I determine project useful life?, the following web-based response is provided. Other help questions concerning documentation and applicability are found in the Help panel. The user can also return to the project list by clicking on the bar labeled Project Generator DFA Police Station, or return to the Help bar. The purpose of the Cost Estimation Info screen is to allow the user to input basic cost estimation information. FEMA has determined that the standard value for project useful life for a generator is 19 years. This value is found in the OMB Circular A-76 entitled Performance of Commercial Activities. Entries for detailed scope of work pertain to the scope of work and various cost estimates necessary for completion of the benefit cost analysis. Selecting Yes for both questions will allow the user to proceed to the mitigation project cost entry. If you do not have a detailed scope of work, you will not be able to proceed with your analysis. If you do not have a detailed cost estimate for the project on hand, you must complete the Summary of Cost Estimation data entries. Links are provided to assist in generating both pre-construction and construction costs. The entry for mitigation project cost should reflect the total project cost to deliver the project as outlined in the application, including project management fees. The annual project maintenance cost entry should reflect the anticipated cost per year for facility maintenance and upkeep of the mitigation components. The BCA tool will calculate a final mitigation project cost based on the initial mitigation project cost and annual project maintenance costs spread over the project useful life. For this case study, enter 19 for the project useful life, $50,000 for mitigation project cost, and $500 for annual project maintenance cost. If the mitigation project cost is based on currently available pricing and not historical, pay special attention to the field, does the estimate reflect current prices? The Yes button must be selected for the tool to function without further input. If the mitigation project cost is not based on currently available pricing, the No button must be selected and additional fields must be populated for cost basis year and construction start and end year. This will allow the BCA software to properly escalate the project costs to current levels. For this case study, select Yes, the estimate is based on current prices. Then select the Save and Continue icon to proceed to the next page. The purpose of this screen is to lead users through the process of determining the loss of function, or LOF, for utilities, roads, bridges, and non-residential buildings, that is, critical facilities like fire stations, hospitals, police stations, and other facilities, and the not applicable selection, which applies to residential or other buildings that do not fit the other available types of services. For this case study, the applicant wants to purchase a generator for a police station. The user should thus select non-residential buildings in the facility type for loss of function data field. We will investigate the use of other facility types after we complete the non-residential buildings category. So for now, click on the Save and Continue icon to proceed to the next page. The purpose of the buildings screen is to allow the user to calculate the total loss of function benefits per day for the facility type being analyzed. The area for selecting facility type allows user input describing the facility via button type selection. Once a selection is made, the appropriate menu box is made available to the user. For example, if the user selects police station as the type of facility, the answers to the questions will be used to calculate the loss of function benefits for that building being used as a police station. The calculation estimates the increasing crime that results from a decreased police presence. It also calculates the increased cost to society of that increased level of crime. If a mitigation project prevents the loss of function of a police station, these would both qualify as losses avoided or project benefits. The first selection to be made is to indicate the type of area served by the police station. The pull-down menu includes selections for metropolitan, city, and rural. For this case study, select City. How many people are served by this police station is the number of people from the surrounding community who would be affected if the police station being mitigated was damaged. Enter 27,000. How many police officers work at this police station is the number of police officers currently based in the police station being mitigated that serves the surrounding community. Enter 119. How many police officers would serve the same area if the police station were shut down due to a disaster is the number of police officers that would serve the surrounding community if the police station being mitigated was damaged. Enter 60. Potential documentation sources for these critical inputs are the police station itself, multiple police stations that would provide additional officers if the police station being mitigated were down, a community planning department, or other reliable sources. Map and distance information can be obtained from a geographic information system or from an online mapping source with a printout of the map used as documentation. Once completed, click on the Save and Continue icon to proceed to the next page. The purpose of the Historical Damages Before Mitigation screen is to enter the historical damage and/or recurrence interval data that the analysis is based upon. For this case study, type 2015 in the Analysis Year data field and type 2000 in the Year Built data field. Analysis duration is automatically calculated. Once the analysis duration has been determined by the BCA tool, the Historic Damages Before Mitigation table information should be populated by the user. The damage year, recurrence interval, and building days values should be entered into the data fields as shown. When entering data in the table, there must be documented historical damages or losses from one or more hazard events of known frequencies that are based on FEMA project worksheets or damage survey reports, insurance claims or repair records, or newspaper articles citing other credible sources. Or there must be documented historical damages and losses from 3 or more hazard events of unknown frequencies based on insurance records, online information from FEMA's National Flood Insurance Program Bureau Net, newspaper accounts when they cite other credible sources, or other documentation not listed, for example, engineering or technical reports or documentation from National Weather Service, NOAA, or the National Climatic Data Center. If there are avoided volunteer costs associated with the power outage at the police station, the amount should be entered in the volunteer costs column. Once your data is entered, select View Damages. The expected annual damages before mitigation values should then appear. It's a good idea to make a mental or written note of the total annualized damages value for future use. Click on the red X or Close button to return to the Historic Damages Before Mitigation screen. Click on the Save and Continue icon to proceed to the next page. The purpose of the Damages After Mitigation screen is to allow the user to enter information related to the effectiveness of the mitigation measure once it is put in place. It is important to remember that most mitigation projects do not eliminate all risk. In this example, however, the standby generator will eliminate all of the impact of loss of power, so the damages after mitigation will be 0. Note that the recurrence interval for all events entered on the previous screen should carry forward to this screen. In this case, the 25-year return interval event was carried forward. Click on the Save and Continue icon to proceed to the next page. The purpose of this screen is to display summary information and to present the value of total benefits divided by total costs, which provides the mitigation benefit cost ratio, or BCR. The top section of the screen displays expected annual damages before mitigation and expected annual damages after mitigation. The next section of the screen, Expected Avoided Damages After Mitigation, or Benefits, shows the impact of the project. The annual and present value amounts shown in this section are the difference between the two respective before mitigation and after mitigation boxes above. In the bottom section of the screen, you see the mitigation benefits data field filled with the present value amount. The mitigation cost data field is filled in with the mitigation project cost that you entered in the cost estimation info screen. The value in the benefits minus costs data field is the difference between the benefits and the costs. The value displayed for benefit cost ratio represents the project mitigation benefits divided by the mitigation costs. You will recall that current federal regulations require a BCR greater than 1.0 for a project to be considered eligible for funding. Click on the Save and Continue icon to proceed to the Mitigation Information screen. From this screen, you could start on another mitigation action for the same structure. For example, you might want to complete a BCA of a different mitigation category for the same structure. Also on this screen, note the View Report link. Selecting this link displays a status report table. The status report table displays the status of the documentation attached to the BCA. The first column lists the screen name, and the second column provides comments. The third column provides either a green check mark or a red X status. The green check mark means that documentation has been attached. The red X means that documentation has not been attached. The fourth column displays yes or no, depending on whether the screen has been opened. The final column displays the text Go. Selecting the text will take you directly to that screen so that you can add documentation and have a complete, well-documented BCA. Click on the red X or the close icon and return to the mitigation information page. In the example just completed, we dealt with the loss of function for a police station that had countered loss of power during a wind event of 25-year recurrence interval. There are several other categories of facility type, including fire station, hospital, and other. These facility types can be selected and used to investigate the cost-benefit of various public service scenarios. Under the Types of Services screen, a variety of critical functions such as rural area water treatment or urban area wastewater treatment plants can be analyzed. The user is prompted to enter the utility facility description, type of service, number of customers served, before proceeding to the balance of the BCA screens. For these categories and all of the facility types described above, the user must have detailed data regarding the project cost, facility type, size of the community of customers served, annual operating budget of the service provider, recurrence interval of the event, and damages avoided. Each specific benefit-cost ratio for the proposed procurement and installation of a standby generator will vary according to local conditions. Thus, this set of instructions is to be used for training purposes only and provides no guarantee of a benefit-cost ratio greater than 1.0. In summary, the Damage Frequency Assessment, or DFA module, is used when there is not enough technical data available to use the full data versions of the BCA software, or the project is to mitigate the loss of function for a non-building, such as a utility, road, or infrastructure. As such, the DFA-Generator module is used for mitigation projects when one or more of the following conditions are met. 1. A generator that is a standalone project can be considered for regular HMGP funding if the generator protects a critical facility. Note that critical facilities may include police and fire stations, hospitals, and water and sewer treatment facilities. 2. A generator that is a component of a larger project, for example, the elevation of a lift station, is also eligible for regular HMGP funding and the use of aggregation is permitted. And 3. Portable generators are eligible provided that they meet all HMGP requirements as described in 44 CFR Section 206.434. It is important to remember with the DFA module that because of its flexibility and dependency on user-provided data, that clear and acceptable documentation is a critical requirement. Documentation that does not support the analysis could result in an application not being approved. This concludes the Mississippi Emergency Management Agency Public Education and Outreach Training video for the Benefit Cost Analysis Damage Frequency Assessment module for the purchase and installation of generators. Thank you for your participation.